Welcome to this last session of NDC Oslo. I am fully aware that I am the only thing in between you and your weekend, but I'll try to make that journey as nice as possible. Now, my name is Markus Dregi, and I work as a software developer for Equinor in a team consisting of 13 developers developing scientific computing software. And we develop many different applications, one being what you could consider a legacy application. Now, I could also talk about our more shiny and new projects, but to be honest, I think some of the most interesting problems that we face, both with respect to computer science, but also with respect to development methodology, comes from this legacy projects. So because of that, I am here today to give you this talk named Strangling Hydra One Head at a Time. Now, to give you a bit of context, I am going to tell you the story of Acht. Now, if you were hoping for it being a Hydra, then I have to disappoint you. And I think you would have to try to find a movie instead later tonight to give you that. But dealing with legacy software, it can sometimes feel like you're chopping one head off and two new comes up. But that's a different story. It is also not about peace. So for the non-Norwegian part of the audience, I can tell you that Acht is the Norwegian word for P, which means that now you got to learn a little bit of Norwegian culture, even though you didn't get to go to Oslo. Now, Acht is an acronym for Ensemble-Based Reservoir Tool, and it was created as a tool to reason about the uncertainty in reservoir models. Because in Equinor, we are producing oil and gas from reservoirs, and the honest truth is that no one has ever gone down and inspected these reservoirs. So we have some idea about what they look like, but we don't know for sure. So it could be that it looks like this. It could also be that it looks like this. And it could be that it looks like this. There are various properties about a reservoir that is interesting. It can be how well fluid moves through the reservoir. It can also be what the reservoir itself actually consists of. So normally there is some water at the bottom, and then there might be oil and gas above. And as you might imagine, we do very much care where that line goes. And it might be like this, it might also be like this. And that is key information for us when we are to plan how to operate a reservoir in the future. Now, what Acht allows you to do is to take a model with uncertainty attached to it, and then basically just spawn a multiverse, a bunch of different universes representing this model, where each and every one of these models is a concrete model with concrete knowledge that you can simulate ahead in time. And by that, you can make forecasts, run simulators, reason about the results, etc. So this allows you to take all of these different universes, simulate them ahead in time, and then use statistics to reason about what you think will happen in this model of yours that has uncertainty. This allows you to say something about the future, but it also allows you over time to compare what you are simulating on the computer with what you are observing in reality. And by doing so, the hope is that you can actually gain improved knowledge of your system. Now, as the name dictates and these examples show, this application was originally made for dealing with uncertainty in reservoir models. But today, we are also using them for our wind farms. We are using Acht to quantify the uncertainty of wind farm models, how the turbulence behaves under different weather conditions, and so forth. So basically, if you have something that you can simulate, but where the model itself has some inherent uncertainty, then debth can be your tool. Now, if you think that this sounds really cool, then you are at luck, my friend. Because actually, at NDC Techtown last year, I gave a talk on the mathematics behind debth. So if you want to know more about that, then you can go to YouTube and check out that talk. But today we are to talk about debth as a software project. And started out with reservoirs and the need for software. Someone had an idea, that idea evolved into mathematics, which again was manifested in software that allowed you to reason about this uncertainty. And this was to a large extent developed by a single developer, which is a massive feat, but it also has some interesting consequences that I will get back to later on. So we have users, scientists, geologists, reservoir engineers that start to use this tool to reason about the uncertainty in the physical object that they are modeling. And this actually imposed a pretty big cultural change in the way that they are working, because suddenly they had to reason not only about the uncertainty of the process that they are doing, but they also had to communicate this to the ones using their results. And furthermore, this uncertainty also had to be communicated to management to really get the best out of these tools. So I imagine that what they faced when communicating this uncertainty is quite similar to what we sometimes face as software developers when we are communicating uncertainty around how long something will take to make what we are making, etc. And to be honest, to give you a bit of hope, it is actually today, as this program has been going for so long, people with the habit of reasoning about uncertainty has also gone up into management. And sometimes, if someone is asking for an estimate because they actually need it to make an informed decision, I sometimes give them probability distribution back, and they are fine with it. And I think that's awesome. So over time, this provided the company with a lot of value because it actually improved our knowledge of reservoirs. So more and more fields started to implement this technology. We got more users needing different features from the software, and the software grew more and more complex. We onboarded more developers to deal with the project, and I have to say that the process was very much feature-driven, which is a good thing because it provided tremendous value to the company. But what it perhaps failed on, to some extent, was to address debth. So debth accumulated in the project in various ways. So for instance, we accumulated quite a bit of technical debt. And as developers, we experience and live in that now, and is dealing with that now. And it basically says something about our ability to move from where we are today to where we want to be. We are slowed down, and we need to pay back and reorganize our software to make it into what both we and our users would like it to be in the future. But even more so, this technical debt is imposing things on our users. So one of the consequences is that they get quite cryptic error messages. And due to not always having coherent feature design, we have actually ended up in a scenario where sometimes one user's feature is another user's bug. And as you saw in the figure, we are to run simulations, but that goes beyond just a single simulator. We also have to take numbers and encode that as a plan in the model. We have to reason about the model afterwards, and a lot of this is happening on the compute cluster. But quite a bit of it also happens on the client side, because we want to reason about across all of these universes. And there is an API for doing this, but it's extremely complicated. So although our users can, in theory, do what they need to do, the complexity and inconsistency of the design of the APIs make very few capable of actually doing it. Another very interesting thing is that the work that our users of this software is doing does in many ways resemble the process of us as software developers. They are suffering from changing context, and they need to be able to focus. They have tremendous insight into the physical object that they are simulating. To me, that is one of the coolest things about this project. It is the enormous amount of knowledge that our users have. But due to that the system is not always so easy to figure out, or that it sometimes gives you strange error messages, what started out as being this vision about how you want to model something or how you wanted to quantify uncertainty suddenly boils down to a cryptic error message that no one understands, and looking in the documentation and trying to figure out how to do something. And they lost this idea about how to model something. So although the tool itself is providing a lot of value today, our vision together with our users is that this tool should, to a much larger extent, be a natural digital extension of their workflow. Another very interesting place where we accumulated depth in this project is with respect to the knowledge. As I mentioned earlier, it was to a large extent a single developer that developed this project. And there is this notion of a bust factor of a project, which says something about how many of your developers could be hit by the bust today, and the project would still move on. And that number was quite low. And this has many interesting implications. One being that a lot of this developer's time is tied up to this project, because new features are coming in, users need support, bug fixes, etc. And since there are not that many others to do it, this developer needs to do it. But when you realize that you have a legacy project and you want to deal with it, then if you decide to do that by also scaling up your team, then you probably know that that is going to cost you time in training, which means that you will have less time for development. So even though it might pay off long term, it is a massive investment to grow a team. So you need to pay back by having knowledge concentrated in few individuals. I have a colleague, Oliver Maudal, and he says that the individual learning isn't worth that much. Learning needs to happen on an organization level. And I think that's very much true. And it's something that we should be conscious about every day at work, not only when dealing with legacy software, but every time we are developing something. Now, there is also a different perspective to this. And that is that sometimes we joke that being the only one that can develop something, or being one of the few that can develop something, is really good job security. But I think that is a false premise, because not only is the developer's time tied up to this project, but the success, speed, and pace of this project is also tied up to this developer. And this developer is still just a single developer, or possibly a couple of developers. And there is a limit to how much they can do. So yes, you have a lot of competence about something that might not and there might not be that many that have that competence. But that is still building on the hope that this project will be a success. And it will most likely only be a success if you're able to have a good development process and adapt as your domain is changing, the requirements is changing, maybe the IT infrastructure that you have to run on is changing, and you need to be able to deal with that. Another thing that you have to address, especially if you're growing a team, is that you need to nurture your culture. I think we had a pretty good starting point there in software innovation, but still when you bring in new people, we have grown our team by more than 50%. You still need to make sure that the culture is even maintained, but also improved over time. And this is also an investment to make sure that you're all pulling in the same direction, but also to ensure that every team member feels safe and trusted, so that they can tell you when they know something, say, this is a bad idea, I think we should do something else. Or tell you that, I don't know this, I don't understand what this means, can you please explain it to me? Only by having that kind of culture can you build a team with a lot of knowledge around what you're doing. And I think it's very interesting, this perspective of building a team with different features and strengths, and you don't have to be good at everything, but you should probably be good at something, and it should hopefully be some of the things that you need to do your job. So as you get better, as your team gets better at doing what they are doing, which is probably software development, I think we need to accept that you can't get better at everything simultaneously. And on this thing, I think we can learn quite a bit from sports science, because they have a lot of theory on this. And they have this concept called periodization, where you accept that some features of you as an athlete or your team can't be improved at this point because you want to focus on something else. You might even have to accept that I will get slightly worse at this, but at the expense or to become much, much better at something else. And you can envision it being a bit like a computer game where you have some character, or in this case, a spaceship that has various features. And then you can decide to improve this part of your spaceship, this part of your character. And then as a team, you might have to accept that we can't fix everything at the same time, because we can get much better at this right now, and then we can try to get better at something else afterwards. Now, so when you start dealing with a legacy application, then I really believe that you need to get the foundation right first. And by this I mean that you need to get your deploys right. You need to be able to deploy your software in an automatic fashion, in a reproducible fashion, and in a safe fashion, so that when you make iterations, you're able to get that out to your users. I remember when I started working on this project, then a large fraction of the new versions, deploying them would break the entire system. And I mean, this isn't a live system. Nothing stops up. Our money stream doesn't stop if the software stops up. But we are simulating things on an HPC cluster. And these simulations can take quite a bit of time. And there are iterations on top of these simulations where you're adapting and changing the parameters to your model. So in reality, our users can lose days and days of work if we go down. And sometimes that doesn't bother them that much, just a little bit. But sometimes they are generating statistics that are to go into decision making. And maybe that decision has to be made soon. And then they are not so happy. So we really needed to get our deploys right. and I think you do as well, if you are to deal with legacy software. You also need to spend time caring for your test suite. We were quite lucky. We had a good test suite already, or at least a decent one. But you need to be able to make sure that when you are iterating and changing your software, that the correctness and behavior is still preserved. Otherwise, you will have no chance of being sure that the changes that you are making will also keep the software doing what it should do. And I think the last thing that you need to do was very surprising to me. But you need to learn to communicate with your users, especially in a complex domain. There is a tremendous difference between both learning the language of your users and also having them learn a bit of your language, lingo. The effectiveness of that communication is just on a different scale than what you had to begin with. And if you want to get a good description of what you should make, what challenges your users are facing, you have to be able to communicate with them. If not, then you're living in a vacuum. And when you've gotten this down, then you can start looking at the architecture of your system, the different components and their responsibilities. And sometimes the boundaries aren't that well defined. Maybe responsibility might be shared between different components that shouldn't share this responsibility. Maybe everything is talking to everything. There is no good structure. But you need to figure out how it is working and how you need to get a realistic image of the architecture today. And then you need to figure out how you would like it to be in the future. And then you need to start making some first steps towards how you would like it to be. This doesn't say that you should follow this plan or that this doesn't change. You have to adapt as you learn and as you go. But starting without a plan, I think, is really naive as well. And also you have to accept that you might have to go through some hurdles and do some not so pretty solutions on your way towards what you want your solution to be. Sometimes when I talk about legacy software to non-software developers, I compare it to building a road network, and you have like a road with a lot of traffic, and then you are to do something with that road. I don't know, build a roundabout or a traffic light or something, and you need to get the traffic over somewhere else to be able to do this work. So you might have to actually create a temporary road. They do this. They create temporary roads to redirect traffic so that they can do what they were supposed to do and then move the traffic back again. And when you have planned your first steps and figured out what you would like it to be, at least with your current knowledge, then you need to find some components that you can start working on, because you can't do everything at the same time. You need to start somewhere. And there can be many ways of finding out where you should start. It would probably be good to find something that is sort of an easy win, not the most complex part of the system. It can also be about in which parts of your system do you expect changes to be able to make the system that your users want. If you see that our users would really benefit from this kind of feature, and that will happen in this part of the software, then it's much better to start with that part than starting with a part that you don't really foresee changing that much in the upcoming future. You need to figure out where to start. Then you can start implementing that part of your new system and starting to redirect and utilizing features from that part as it gets made. And it is easy to get lost in this kind of work. So you really need to make sure that the new stuff that you're making is good, has high quality, and allow the developers to make something that, so that they don't lose sight of what good quality is, that they suffer from severe quality fatigue. I'll get back to that later on. And when you start making these changes, you should, as always, encapsulate these in like small deliveries. And hopefully you can make many small deliveries. And you can only do these changes if you already made sure that your test suite is decent. If not, then you will stumble already here. And afterwards, you need to make sure that these small deliveries actually get out to your user. Which means that, and you need to do that often as well, you want each of these small deliveries to actually reach out to your users. And you won't be able to do that without dealing with and ensuring that your deploy system is good. So if you fall in the trap of starting to deal with the code without having the necessary tooling, deploy scripts and tests ready, then that will really come back to bite you. And also you need these deploys to actually get to the users, and to get to the users often. Now, one of the challenges with this, when you're dealing with refactoring and rewriting code and managing legacy systems that you want to modernize, is that many of these changes, at least at the bottom level of your application, might not even hit the users. They should hopefully not even recognize it while you're just starting to pull it apart and figure out how it should be like. So now maybe you need to rethink what your user is. Maybe your user actually is a colleague, a developer in your team that is now consuming your new API, or utilizing a new feature that came up, or a more coherent fashion of interacting with this module. And then you should make sure that your deliveries actually reach out to their development environment, and that you can get feedback. And if you are to get feedback both from the users and from these developers, then you need to have established this language of communication so that you can understand how changes are impacting them, or what kind of features they would like to see in the future, so that you know where you should start addressing the legacy of your system. So you need to get that in place. Also, I have to say that when you're dealing with technical depth and knowledge depth, then there are times, as we mentioned, where you don't necessarily deliver that much new functionality to your users, because you're dealing with the depth of the system. And this really requires a great deal of trust between you as developers, the users, and the product owner. Spending time on nurturing that relationship and understanding their needs and explaining the consequences of the work you do today and what it will enable you to do tomorrow, I think that is a really important conversation to have. Now, as I mentioned earlier, you really do need to manage quality fatigue. If you're operating in a lot of technical depth, you might, over time, to avoid becoming crazy, actually lower your standard of what you think good quality is. When you start strangling your software and making new modules, really make sure that they are as good as you possibly manage to make them right now. You need to create these happy zones, safe places in your project that has maybe even a higher quality than what you hope that the system in total will have. Something that really separates the quality of the new parts from the quality of the old parts. Also, you should really make sure to don't let your colleagues get lost in the wilderness of legacy code. We have something like 1.5 million lines of code in C and Python. And sometimes you start out with something that appears to be an easy problem, and then you start addressing that problem. You disappear down into the code, and at some point you lose track of what's going on. You get so focused on the problem that you're trying to solve that you forget about your implication of what you're doing to the design. Maybe you're imposing changes to the design of the API that makes it less coherent than what it was. Maybe you're adding strange things to the build scripts to avoid the hoops, no, to get it working, and then you don't realize because you're so focused on the problem that you're trying to solve. And in addition, in Equinor, we have something called playground time. And I think that is also a very useful tool to actually manage quality fatigue. So then you get to spend some time to do something completely different, just learn new techniques and new technologies. And I think it's really important to recognize that both by setting a really good standard in these new parts of the project, as well as doing, for instance, this playground time, that will really help you back into managing the rest of the computer system. Now, to cite Martin Fowler, he says, let's face it, all we are doing is writing tomorrow's legacy software today. And I think that's true. And I think we need to embrace it. And honestly, I think maybe that's even the most positive spin, the most positive view you can have on this. Because if you're not writing legacy right now, then you are most likely writing a software system that over time will not be relevant and then just disappear again. Of course, you will have to manage your debth and improve it and make sure that you can iterate on top of your project in the direction you want it to go in. But I think you also need to embrace that you are writing legacy software right now. I read this quote about growing up some weeks back. I didn't manage to find it again, but it basically boils down to that becoming an adult is coming to peace with that the people around you are nothing but humans. And I think maybe we need to do the same as developers. We need to realize that the code that you are screaming over today was written with good intentions and maybe even was a very good decision at the time when it was written. But tooling changed. Maybe new solutions came around. We learned more about software design or about interacting with our users. Maybe the domain changed completely, or maybe the idea of their entire IT system changed and you want to do something else. So I see that I have spent a little less time than I was planning to, but I now get to conclude my talk. That is the benefit of being a speaker, then you get to conclude. So we need to leverage depth wisely, and that goes for all software projects. If you want to move and get somewhere, then accumulating depth might be the fastest way to get there and the best way to get there. Maybe you should just prototype a feature, see how it goes. Maybe it isn't relevant, who knows? So implement it, get it out, get some feedback, but be sure that you also are aware of that depth and that you manage it. Or let someone on your team dig deep down into some topic that you might think will be relevant for how to solve a problem that you're currently trying to deal with in your team. Let them learn something and figure out how something works, and maybe even implement a solution. But then also be aware that that knowledge gained by that person is currently only living there. So make sure afterwards that that knowledge is then fed back into the rest of the team. It allows you to move quickly, but you also need to mitigate afterwards. Also, if you are dealing with a legacy project, then I will highly encourage you to strangle your Hydra iteratively. It's extremely difficult and maybe even impossible, I would say, to do everything at once. You need to iterate your implementation and make sure that changes that you are doing get to your users in a good fashion. And then you can iterate on top of that again afterwards. And last, realize that the code that you are writing today is the legacy of tomorrow, and make that legacy the best you can. I think that we have quite a tendency to be aware of abstractions when we are designing software. We try to do this, of course, they start leaking over time, and maybe it shifts as the domain evolves and so forth. I think we as a community try to do that quite well today. But I personally feel that we sometimes today let the architecture leak too far into our software solutions. I'm not saying that that shouldn't happen, because that's what architecture decisions are. You're making big fundamental decisions for your software project. It will, by its very nature, be costly to change. But that doesn't mean that you have to let it flow into every single piece of your code. So I think that is something that I hope we as a community will find even better ways of dealing with, even in a cloud-native kind of architecture in the future. And last but not least, this app project is actually open source, so you can check it out. I think that is also one of the things that you need to embrace when dealing with legacy code. I mean, it is legacy because it provides a lot of value, so that's really, really cool. And also you have to identify with the direction of the project and what is currently going on. And by making that very good, the direction of your project, if you then also in addition apply time, then in the end, you will be able to make an impact on the state of your project. And that is what I have to say. Thank you for listening. And yeah, feel free to shoot questions.